Hello friends, today we shall discuss about speciation and different types of speciation. Okay, speciation. What is a speciation? Simply means it's a process wherein splitting of a genetically homogeneous population into two or more populations followed by genetical differentiation eventually leads to reproductive isolation, what we call speciation. That means there are three important steps. One, a parental population. Subjecting to a different environment that leads to genetical differentiation that leads to reproductive isolation. This is speciation. Based on the kind of speciation, there are different types. One, Allopatric. Two, Sympatric. Three, Parapatric. Allopatric speciation is facilitated by geographical barriers. So it is otherwise called geographical speciation. Sympatric speciation is facilitated by the reproductive isolation. Here there are no geographical barriers. Reproductive isolation. Sympatric speciation, here also there are no geographical barriers. It is about reproductive isolation only, but in a same area, that means adjacent areas. Para means near. That means mostly it is by reproductive isolation in near areas. Para means near. Okay. So allopatric is because of geographical barriers. That means geographical speciation. Sympatric speciation is because of reproductive isolation, and parapatric speciation is because of reproductive isolation in near areas. Okay. We'll discuss one by one. First, allopatric speciation. Allopatric speciation. Here, at first, the parental population divides or separated into a small population or a small group of individuals separated from the parental population because of a geographical barrier, maybe because of ocean or a desert or a mountain or even some distant issues also. And because of this particular geographical barrier and this small group of population start adapting to the new environmental conditions, that leads to genetical divergence with that of the parental population and eventually leads to reproductive isolation, then evolution of a new species. Simply called a geographical barrier, then a reproductive isolation. For example, say a small group of individuals, it's a parental population. It's a parental population. Because of its specific geographical barrier, it splits into population A and it is population B. This is geographical barrier. And this population A gradually evolves into species A and this into species B. Why? Because there is a reproductive isolation. Means their gene pool is distinct. They are not allowing other genes to enter. There is no interbreeding, though there is a capable. Of course, here there is a geographical barrier. Here, reproductive isolation mechanism is extended in such a way that means that leads to speciation, that even though they reunite species A and inhabit one particular area, they won't interbreed. No interbreeding. That's what we call species, a dynamic group of individuals interbreeding among themselves, maintaining distinct gene pool. They don't want to share their genes with others. That's how allopatric speciation, because of the geographical barrier, the parent population splits into two, A, B, and this B, they gradually evolve into species A and B because they start accustoming to, that means adapting to new environment. Here environment A and environment B. Then followed by species A and B because of reproductive isolations, and ultimately two new species A and B. The best example is Darwin's finches. Darwin's finches. South American ground finch. Geospiza. Okay, is genus. From the parental population, that means inhabiting the South American continent, these Darwin finches, they colonize in different Galapagos islands, a group of islands, that means Galapagos archipelago off the coast of South America. Say, this is South America, for example. South America. And small group of islands. If we just I would like to magnify. Say, this is one island called Isabella. Say Pinta, Santa Cruz, Santiago, Hispaniola. These are different Spanish islands, okay? Isabella, Pinta, Santa Cruz, Santiago, Hispaniola. That means Darwin finches inhabiting these different islands evolving into separate species because each island environment is different from the others. According to the kind of environment, they start evolving by appropriate character, because genetical divergence developed at first because of the geographical isolation. The ocean is a geographical barrier here, the Pacific Ocean, and this genetical divergence ultimately leads to reproductive isolation. There is no exchange of genes. They are maintaining distinct gene pool, though they are not interbreeding, though they have this capacity, because there is a distinct reproductive isolation here because of geographical barrier, and ultimately leads to separate species. That means Isabella, Pinta, Santa Cruz, and other islands, each one is different from others, because it's a best classical example for allopatric speciation, simply because of geographical barrier that in turn leads to reproductive isolation, and that ultimately leads to allopatric speciation. It is also best example for founder effect, because it's a small group of individuals. That is very important, because in small group of individuals the mutation rate is random, rapid. It's like they start accustoming to the novel environment in a quick way, and also the chromosome evolution is. That's why they become evolving into new species. Okay, this is about allopatric speciation, otherwise called geographic speciation. Right, this is very important. Next, sympatric speciation. Sim, the name it implied. Sympatric, the name it implied, they live together in one habitat, one particular habitat, but in different ecological niches. That means the parental population, they live in one particular habitat, but they evolve into new species. And yes, a group of a population, that means a group of individuals, what we call a separate population, evolve into a new species in one particular habitat. That is called sympatric, living together. Why and how? It means inhabiting different ecological niches in one particular area is matter of concern. Of course it is, and it should be coupled. There should be a reproductive isolation. That means speciation in one locality, simply called, because of reproductive isolation. Why? Why the reproductive isolation is extended in such a way that it leads to speciation within one particular locality? What makes them so aberrant? There are different reasons, like polyploidy, change in chromosome number, intraoperative hybridization. That's one other example. And how the change in chromosome number? Because of aneuploidy, haploidy. There are different reasons. It's like change in the exact chromosomal number is aneuploidy, simply it means. Euploidy is a real number, aneuploidy is an abnormal number, either increase or decrease. Because of this, reproductive isolation is existing or establishing, and that leads to speciation in one particular locality. So, because of just like at chromosomal reasons, or genetical reasons, or molecular reasons, the reproductive isolation mechanism come into existence, and that leads to sympatric speciation. It is most common in plants when compared to animals, because of this kind of nature. And in case of animal, the best example, Drosophila melanogaster. Four pairs of chromosomes. Drosophila virilis, 6 pairs. That means there is a difference in the, as I said, aneuploidy, there is a difference in the chromosomal numbers that leads to the mechanism of reproductive isolation. In case of plants, wheat, sugarcane, cotton, tobacco, there are several terrific examples, because it is more possible. That means sympatric speciation is more common in plants and very few in animals. So, reproductive isolation is the crux point for sympatric speciation. Okay. Then the final one, the parapatric speciation. Parapatric speciation. The name it at para means near, like adjacent. Say there is a, that means because of that he has speciation because of a reproductive isolation in a continuous population. Here there are no geographical barriers, but there is a reproductive isolation mechanism in a continuous population. That means they are near, it is parapatric speciation. For example, there is a large is a scale of one particular population, okay, area. This is one environment, this is another environment, this is another environment, and this is environment A. That means it's called environment A, population A, environment B, population B, environment C, population C, environment D, population D, A, B, C, D, and there is an ecotone. It's called environmental margin. So boundaries between different environments, ecotone, okay, and there is a peripheral or a narrow, thin, overlapping region of different populations. Where there is a possibility of hybrid population, but it restricted to peripheral regions only, what we call overlapping regions. But in general, on the whole, they had their own populations because of reproductive isolation. That means speciation in near areas, adjacent area, but in a continuous population is parapatric speciation. Okay, this becomes one pieces and one. It's because of same area only they habituate, because of but different environments. Say the land snail, the best example. So, but when it's about parapatric speciation. So far we have discussed about allopatric, sympatric, and parapatric. And there is one more division of speciation depending on the number of species evolution. It is called the phyletic evolution or anagenesis. Number 2, cladogenesis or divergent evolution. What is anagenesis? Here simply one species, that means species A becomes species B. One species evolves into another species. Where in case of clad, different groups, it splits into 2 or more different populations, eventually speciation. Different subpopulations, you can say eventually subspecies. Cladogenesis or divergent evolution. Okay, in simpler sense, say anagenesis or phyletic evolution. Species A evolves into species B. Okay, this is one kind. Number 2, cladogenesis. We got divergent speciation. Simply, a species A evolves into 2 subclads, say B and C. Clad, they differentiate, that means one particular species into another is A into B and C also. That means divergent evolution. Okay, so anagens is one species evolved into another species, whereas cladogens are divergent evolution. One species become two or more populations. So at the layman language, a process wherein one species evolves into one or more species is speciation. Okay, we'll discuss some other in some other class about some other topic. You can subscribe. You may subscribe.